Hello everybody, I'm going to be talking about odd and even functions today. So the basic definition of an odd function is this: f of negative x is equal to negative f of x, and the basic definition of an even function is f of negative x is equal to f of x. Now, what this tells us is if you substitute negative x in, for example, this function, so if you substitute negative x in p of x, um, and you get p of x back, it back, then it's an even function. So let's do this problem here. Let's do an example. So if we take p of x, let's do it in yellow. So if you take p of x and you substitute a negative x right there, so you're going to get 4 times negative x squared plus 3, and if you simplify that further, so you're going to end up getting 4x squared, because remember, negative x times negative x is x squared plus 3. Then you have essentially got p of x back, because remember, p of x is equal to 4x squared plus 3. So what this tells us is, since p of negative x, um, it satisfies the condition that when you substitute in a negative x in the function, you get that function back. It's an even function. And let's do an example for an odd function. So in this case, I'll tell you that g of x is an odd function, and if I solve it right here, so negative x, so negative x cubed minus negative x, and if I simplify this further, I'm going to get negative 8x cubed plus x. Now at this point, you know that this is not an even function, because after we substituted in a negative x into the function, we did not get the function back. Because remember, our original function is positive 8x cubed minus x, and this is negative 8x cubed plus x. But if we were to factor out a negative 1, or actually you can write it as such, 8x cubed minus x, now you will have noticed that you've got the function back if as soon as you factor that negative 1 out. So in essence, you can write this as negative g of x. So since we have now satisfied the condition for an odd function, so this right here, the fact that f of negative x is equal to negative f of x, we know that this function is odd. But you must be wondering, well, why would you do this? Why would you determine if a function is odd or even? Well, the biggest thing a function, the, knowing if a function is odd or even tells you is symmetry. So, and that really helps when you're graphing the function. Now, intuitively, you know what how the function of p of x would look like. It's a parabola that has been shifted 3 units up. So, if we were to draw that function, if we draw p of x, it would look like this. And what odd or even functions tell us is that for odd functions, there will be point symmetry. So there will be point symmetry about the origin at the origin. And for even function, it tells us that there is line symmetry um, about the about the about the y-axis. Y-axis. There you go. Okay, so from this function, we can tell that it is definitely even because we've proven it right here. And when we graphed it, there was line symmetry about the y-axis. So that's the y-axis, that's the x-axis, and there is line symmetry right there. So this is now for this function, it was pretty simple to draw. So we didn't it didn't really help us a whole lot here. But for some of the more complicated functions, knowing that it's got line or point symmetry really helps. Now similarly with this function with g of x, if we were to graph that, we would get something like this. Now this is not, it's a sketch of course, it's not accurate, but you would get something like this. Alright, and knowing that this function gives me line symmetry, it's very easy to sketch because it gives me point symmetry. So odd functions give you point symmetry. Um, so what a point symmetry means is that if you were to rotate this part of the function, so if you were to rotate this part of the function 180 degrees, so all the way around here, 180 degrees, you would get the same, you would get this part of the function right there. And what a line symmetry tells you is, as I mentioned earlier, if you were to reflect, say, this part of the function about the y-axis, were to reflect it like that, you would get this part of the function. Alright, so that's all you have to know about line and point symmetry and what odd and even functions tell you. Well, let's take a look at f of x. Now we want to determine if f of x is odd or even. So let's use our tools here. So let's sub in a negative x. So f of negative x is equal to 3 of negative x cubed minus 2 negative x squared plus negative x plus 3. And if we simplify it further, we're going to get negative 3x cubed minus 2x squared minus x plus 3. Now at this point, you know that it's not an even function because when we substituted in a negative x, the result of the simplification does not yield our original function. So as you can tell, our original function is positive 3x. This is a negative. It's a negative 2x squared. It's a negative 2x squared here as well. And that's a positive x. This is a negative x. So we know that it's not an even function. Now let's check if the function is odd. So let's factor out a negative 1. So we're going to get positive 3x cubed, positive 2x squared, positive x, negative 3. Now once we've done that and we look at the content inside the brackets, if you will, you can tell that it's not an odd function either because the function inside the one we factored out, the negative 1, we did not get the original function back. So, as you can tell, this is a negative 2 here, negative 2x, and this is a positive 2x here. So since it's not odd nor even, this function is neither. It's not odd or even. And that's all you have to know about odd or even functions, and if a function's neither odd nor even. I hope you enjoyed watching this video, and let me know how it did.